Hello student, welcome to this computer networking and security session. In the last video, we have discussed the router architecture and various components of the router. In this video, we will move to IP4 version protocol, that is Internet protocol, and here we will see IP4 addressing and IP4 version 6. So according to your syllabus, there is IP4 version 6. According to video syllabus 18CS52, IP version 6 is there, IP version 4 is not there. But still, let me give brief introduction to IP version 4 datagram, I mean header format, and IP version 4 addressing scheme. So now, network, the main job of the network layer, is, so students, we have studied in our last session like the different layers of TCP model. Let me discuss that here once again. There are 5 layers in TCP model. One is called as transport layer. First one is application layer. So first one is application layer. So second one is a transport layer. Third one is actually internet layer or network layer. Fourth one is data link layer. And the last one is physical layer. So these are the 5 layers of TCP model or DoD model. We have already discussed in the previous session the function of transport layer. Now we will discuss the function of network layer. So what is the actually function of network layer? The function of network layer is something called as routing and logical addressing. Routing means sending packet from one network to the other network. Like sending packet from one network to the other network is normally called as routing. And logical addressing is nothing but each and every machine on the network has got one address. Each and every machine is on the network as identified by one address, that is called as logical address or IP address. It is not physical, it is logical, means you can change this address, and it is a structured address, IP address. This is called as IP address. So two functions of a network layer is, one is routing, second one is a logical address. So what are the protocol comes under network layer? We know like transport layer, the protocols we have already discussed is TCP and UDP. So network layer, the different protocols are there. The protocols are classified as routing protocols and routed protocols. The example for the routing protocol is, the function of the routing protocol is like path selection. It will select the path and it will construct the routing table. For example, routing protocols are the RIP, OSPF, BGP. These are the routing protocols we are going to discuss. Routed protocol, the other category of protocol is called as routed protocol. So routed protocol, the job of the routed protocol is to pass the data, to move the data from one place to the other place, or from one node to the other node. The main job of the routing protocol is to determine the path. Once the path is determined from the source to destination, then the data will be moved from the source to destination by the routed protocol. So what are the example for routed protocol? The example for routed protocol is IP protocol. In IP we have IP version 4, IP version 6, Then we have some other protocol from Novel that is called as, nowadays we are not using this to such extent, that is called as Internet Packet Exchange, IPX. These are called as routed protocol. Once again I repeat, the job of the routed protocol is to move the data from the source to destination. The job of the routing protocol is to construct the path. So how the routing protocol will construct the path? It will select the path. It will select the path based on certain algorithm, and this is the example for routing protocols are called as RIP, OSPF and BGP. Other protocols are also there. We will discuss that in later. So routing protocol, what that routing protocol will do, it will construct the routing table, and the name and the same the other name for that table is called as forwarding table or routing table. Other than that, we have one more protocol in network layer that is called as ICMP. ICMP means Internet Control Messaging Protocol. The main function of this protocol is error reporting. For example, when you use normally we use the ping statement to check the network connectivity. We use ping statement to check the network connectivity. So we use a ping statement to check the network connectivity. So ping statement to network to check the network connectivity. Suppose I use ping statement to check the network connectivity between the routers. Like this is the source router and this is the destination router. For somewhere in between, C and B, there is a break in the network. There is a break in the network means C and B are not connected and there is a break. C cannot transfer data to B. When I ping from here, using ping utility, ping to B, I will get error message saying that host is not reachable. So this function is handled by ICMP protocol. So the main job of the ICMP protocol is like error reporting. So the utility ping makes use of ICMP protocol. So this is the introduction about the network layer. Now we will move to the next slide. So here I am going to give you a brief introduction about IP version IP header. Then we will move to IP address. So IP datagram format. Before that, before discussing IP datagram format, the PDU, we know what is PDU, protocol data unit. PDU at transport layer is called a segment. The PDU at transport layer is called a segment. That is data, whatever upper layer data that is received by the transport layer will add its own header, and it will divide that data into different segments, and it will add its own header. That is called as the segment. When that particular segment is moved to the network layer, and then it is called as a packet. So PDU at network layer is called as a packet or datagram. That means whatever data received from the upper layer, for that network layer will add its header, and that is called as a packet. So what is there in that header? That header is nothing but IP header. What is there in that header? So we are going to discuss that one now. So now here you see IP datagram format. This is important, even though it is not there in your syllabus of 18CS52 VTU syllabus. Still it is necessary to understand IP datagram format and IP address, etc. So there are different fields in the IP datagram format. You can see here the different fields are version, header, type of service, length, 16-bit identifier, flags, fragment, time to leave, upper layer, header checksum, 32-bit source address, destination, and etc. So here, like header size is 20 byte. For example, this is the width of this datagram is the width of this datagram format is around 4 bytes. So 4 bytes into we have 1, 2, 3, 4, 5, and option is different. Option is different. Other than this, data is variable. So 4 bytes into 5 rows means 20 bytes. Please remember, like both TCP header and IP headers are 20 bytes in 20 bytes long. Now what are different field? The different fields are here. You can see First one is the version. Version indicates different types of version handled by the router. So here 4 bits are allocated for the version. 4 bits are allocated for the version. These 4 bits specifies the IP protocol version of the datagram actually. By looking at the version, the router can determine how to interpret the remainder of the IP datagram. How to interpret or the interpret the remainder of the IP datagram. Second one is called as header length. So, because an IP datagram can contain a variable number of options, so it is necessary to include header length so that it will come for router can conclude where the actually data begins, in the datagram. That is the second option. Third option is type of service. Type of service includes different bits. Here type of service actually includes provides different types of services for the different different datagram. So actually datagrams are particularly requiring low delay, high throughput or reliability. So based on this, datagrams are distinguished from each other. So in order to provide different types of service based on this, these 3 fields are used, and length indicates the total length of the IP datagram. Other than that, we have something called as identifier, flag and fragment offset. Identifier, flags and fragment offset. These 3 fields so have to do with the so-called IP fragmentation. So fragmentation means when IP datagrams are moved through different data link, based on the data link capability, the IP datagrams are further fragmented. In order to identify the fragments, all these 3 fields are required, that is identifier, flags and fragment offset. Other than that, we have something called as time to live. Time to live field is included to ensure that datagram don't circulate forever in the internet. So don't circulate forever in the internet. It will avoid the looping of the datagram in the internet. So this is called as time to live. Then upper layer. So upper layer indicates which of the upper layer protocol. So in the DoD model, the upper layer corresponding to network layer is the transport layer. So transport layer can handle, transport layer has got TCP and UDP. So here either TCP or UDP protocol, which of the upper layer will handle the particular data, that is mentioned here, upper layer protocol. Header checksum. Header checksums are used for checking the integrity of the data. Other than that, we have 32-bit source IP address of the source machine and IP address of the destination machine, IP address of the source machine and IP address of the destination machine. So this is about IP datagram format. Now we will move to other information. What is IP address? So students, here you can see summary whatever right now I explained. It is like you should remember here 20 bytes of header size for TCP as well as IP. You should remember this point. Other than that, I have already explained all the other fields of this IP datagram format. Now we will move to the next slide. So student, IP fragmentation is the one field in the IP header format. So what is the use of IP fragmentation? I told you. So you can see here exactly. See, when any packet arrives, based on the size of the capability of the link, data link, then the packet can be further divided. Means suppose if this link cannot handle for example more than 500 bytes of data, and the here packet size is around 1500 bytes, then this packet is further divided. Here you can see the packet is further divided into smaller datagram, and to identify the datagram, this process is called as a fragmentation, and all these datagrams are identified by means of flags and fragment ID and identification ID. Now the next concept is IP address. So every machine on the internet is identified by one logical address, that is called as IP address. Every host But if you see the router has got multiple interface. This multiple interface, so the router has got multiple interface. This multiple interface has also identified by multiple IP address. In the diagram you can see, in the diagram here you can see, this is one network and this is one network, and this network is identified by means of IP address. So here IP address is mentioned like 223.1.1.1 in dotted decimal format. So here the router is there. This router which connects all the three networks. And this router has got three interface, and three interface also identified by particular IP address. For example, here you can see 223.1.1.4. So this interface belongs to this network, that is 223.1.1.1, 223.1.1.2, 223.1.1.3 and 1.4. Similarly, this network is 223.1.2 network. In two network, first host, second host. Similarly, here some identification is given for the host router interface, that is 9. Similarly, we have 223.1.3 network. In 3 network, first host, second host, like that. For the router identification is given 27. So IP address is a dotted decimal format. So same IP address you can represent in binary format. So each digit or each this one here, each digit are represented by 8-bit number here. Here 223 is represented as binary like this, 1 is represented like this, and like this. So this is the 32-bit binary numbers. So every interface of the router is typically identified by one IP address. That means IP address is associated with each interface. So students, as I said, IP address is a 32-bit address. The IP address is represented in dotted decimal, that is 32 bits are represented like this. So IP address is a hierarchical structured address. That means it is divided into different classes like class A, class B, class C, class D, class C. Class A, in the class A, 8 bits are allocated for the network. Actually, 8 bits are allocated for the network and 24 bits are allocated for the host. Class B, 16 bits are allocated for the network, 16 bits are allocated for the host. Class C, 24 bits are allocated for the network and 8 bits are allocated for the host. Like that, we have class D, that is called as a multicast. It is used by the routers to share the routing informations. And class E is nothing but reserved. It is reserved for the research. So like this, we have 5 class of address, but in that mainly 3 classes are used: class A, class B, class C. This is with respect to IP version 4 classification. I am talking this one with respect to IP version 4 classification. Now we will see the design of class A. Class A. So the design rule of the class A says like the first bit should be 0. So let me zoom it. The first bit should be 0. As I said, like in class A network, 8 bits are allocated for the network and rest of the bits are allocated for the host. That means in 8 bit, first bit is 0. Like in 8 bit, first bit is reserved. That means 7 bits are available. 7 bits means 2 raised to power 7. That means 128 combinations. That is 0 to 126. 127 is called as, it is used for testing purpose. So 0 to 126 networks are available. 0 to 126 networks are available. 0 to 126 networks are available in class A net, this one. And how many hosts are available in the class A actually? See, in the class A, 24 bits are allocated for the host. 24 bits means 2 raised to power 24. 2 raised to power 24 gives like 16 million hosts. 16 million, around 16 million hosts. That means in class A, number of networks are small. Just only 127 networks, class A networks are there in throughout world. But host is like each network can handle 16 millions of machines, each network. So such a big network, and to manage that big network, you have to subnet the network. That is different concept. We will see that later. Now next one. Next one is class B. In class B, let me zoom it once again. Class B, 2 bits are reserved. So as I said, class B, 16 bits are allocated for network. 16 bits are allocated for network. actually. In that 2 bits are reserved. So how many bits are left over here? The leftover bits are like leftover bits are 14. 2:14 means 64,000. I'm sorry, 16,384 networks are available. So 2:14, 64,384 networks are available. So range is from 128 to 191. So range comes from 128 to 191. So in class A range is 0 to 126, 0, it is not 1. Actually we nowadays we are not ready to leave 0 address also, 0 to 126, and class B 128 to 191. But how many hosts are possible? For host 16 bits are allocated, 2⁴16. 2⁴16 bits means around 65,536 hosts are available. So class B is used for a medium size network, class A is used for large size network. Now we will move to the next one, that is class C. You see class C, in class C 3 bits are allocated for the reserved. That is a design rule, 3 bits are reserved. That means you see here total bits is allocated is 24. Network 20 bits, 24 bits are allocated. Out of that 3 bits if you leave for as a design purpose, then 21 bits are available. 2⁻21 means around 2,097,000 networks are available. How many hosts are available? Host is like 8 bits are allocated host. So 8 bit means 256. In that we have to leave the first host and last host, that is unusable. First number, that is 0, and the last number is broadcast. It is called as a broadcast. That address is unusable. So if you deduct that one, 254 hosts are available here. So you see class C is actually speaking, class C contains many networks, but the size of the network is small. Capability of the network that can handle host is small, like only 254 hosts it can handle. Class C 254, but size of the networks are large number of networks are there in class C. So now next, like that we have other range also. Class D is in the class D 4 bits are reserved and range is 224 to 239. Similarly we have range for class E. Class E is from 240 to 254 in that range. So class C. So totally we have 5 class A range. Let me write here. Class A range is, I will write the range here for class A. Class A range is 0. Let me use this pen. 0.0.0.0 to 126.255.255.254. This is the range of class A network. What is the subnet mask of the class A? Subnet mask means which tells which portion of the this one address is a network address. So subnet mask of the class is 255.0.0.0. You know logical ANDing. So when you do logical ANDing here, you convert this bit into binary and you do logical ANDing, then you will get this is 0, this is 0, this is 0, and this is 126. That means it will tell 126 is the network address. 126 is the network address. In that 255.255.254 is the host address. So this is a range, and the subnet mask I will write here. Subnet mask is equal to default subnet mask, we call this one is 255.0.0.0, or in Cisco prefix. Cisco makes use of a prefix instead of subnet mask, where we will call /8. 8 bits are allocated for the network. So that is the one thing. And in class B, the range for class B, let me write here, the range for class B is 128.0.0.0 to 120. Actually it is 0.0.0, so instead of 0 I can take it as a 1, because for host you can't give 0 address. 1, that is better. 120, 191 dot, so let me go back and erase that properly. So this is 1. So 191.255.255.254. And what is the subnet mask for class B? 16 bits are used. So that means 255.255.0.0 or /16. 16 bits are used for networking. Then this is class A, this is class B, and class C range is 192.0.0.1 to 223.255.255.254, and subnet mask for class C is 255.255.255.0/24. 24 bits are used for networking and 8 bits are used for host. And class D, we know range, let me write here range only, class D 224 to 239, and class E is equal to class E is 240 to 254, some range. So this is the address range, class A, class B, class C, class D. But in this range we have something called as a routing address and a private address. Routing address you need to purchase from a internet service provider. So all the machine we can't purchase routing, routable address, because it is not economical. So what we do is we will use a private address. So in every class there is a private address. So every class there is a private address. Let me write in the class A what is the private address. So class A private address is range is, let me use the new pages. So class A private address range is something like 10.0.0.1 to 10.255.255.254. This is the class A private address range, class A private address. This address can be used by any organization internally. It is not routable address. So this address is mapped to public address by means of NAT concept, NATing, by means of NATing. Class B private address is something like 172 dot 0.0.0 to 172.31.255.255. This is the class B private address. Similarly, we have class C address, that is 192.168.0.0 to 192.168.255.254. This is the class C private address. Let me repeat once again. Private address is used by the organization internally to access the machines. When organization connects their machine to the this one internet, they cannot connect it by using private address. But what we do is we cannot buy enough IP addresses for all our machines. It is not economical. So IP address is also not available in that range. So what we do is we will map private address into public address. For example, 10 private address are mapped to one public address by the concept of something called as NATing. That is a different concept. So like this, these are the concepts related to IP address. So before winding up this session, I have to discuss here what is subnet. Subnet means dividing the major network into smaller network for administrative purpose. For example, suppose as I said, I have only 50 machines in my network. I have 50 machines in my network. So for 50 machines, I use IP address, class C IP address, that is 192. Let me write here 192.168.1.1 to 192.168.1.50. Now rest of the address like 51 to 250, class C can host, address around 255 host. So here I am using around I am wasting around 200 addresses in order to utilize the address properly, so that I can subnet this one and I can use the address, remaining address to rest of the network, or I can create my own network at other place and I can use that subnetted address. So that is called as subnetting. So one more concept I need to discuss here, that is called as dynamic host control protocol or configuration protocol. Like how the machine get IP address. Machine can be configured by means of manually. That is, IP address of the machine can be configured by means of manually or by means of automatically. Manual configuration works when there are a small number of machines, like the number of machines are very less, like around 50 machines or 10 machines or 50 machines, something like that. But if you have 1000 machines or 10,000 machines, every time it is difficult to configure the machine, and the process is tedious to remember all the various configuration informations. So there is one protocol that is called as dynamic host configuration protocol that is a plug and play protocol that will assign IP address to the machine automatically. So you can see this one. So in the goal of the dynamic host configuration protocol is to assign IP address for the network, so for the machine. So here there are 4 stages are there, that is called as host broadcast, that is DHCP discover, DHCP offer, DHCP lease request, DHCP request and DHCP acknowledgement. So here you can see the 4 stages. Before that you see here you see 3 networks are there actually. These 3 networks IPs are assigned by DHCP server. DHCP server is there in one network. So suppose this machine wants the IP address, then when the machine enters into the network, it doesn't have any IP address. Then it will broadcast for asking the IP address. Then DHCP server will respond and to this broadcast, and DHCP server will assign IP address and other information like DNS, gateway, all those informations. So now you see here, 2 things. One is the DHCP server, one is the arriving client. So arriving client will send a broadcast. It is not unicast. There are 3 things: broadcast, unicast and multicast. Broadcast means arriving client doesn't know who is the server, so it can't use unicast, it has to use broadcast only. So it broadcasts saying that is there any DHCP server out there. So now this broadcast is received by this DHCP server and this will respond. So in that broadcast message, client will give its identity, something like this. So for that, server will respond, yeah, I am the broadcast server and here is the IP address you can use. Now this is the IP address here. You see the IP address given by this client server to the client. If this client want that IP address, if it is okay with that IP address, the client can take that IP address, or it can take IP address from some other DHCP server also. And finally there is acknowledgement from the server. So now the server will give IP address to the client on lease basis, means for so many number of hours or so many number of days, something like that. It is based on the configuration of a DHCP server. Like this DHCP client and server scenario works. So you can see here how DHCP works by animation. And we know DHCP protocol comes under the application layer of the DoD model. So next, other than that, here one more concept is there, that is called as route aggregation. Route aggregation means summarization. So the ISPs, what they will do is they will, whatever the address they get from INA, Internet Address Numbering Authority, what they will do, they will divide the address and they will assign the address into as a block to the different organization, but they will summarize that address to the outside world. For example, here organization 0 has received this as address 16.0, 18.0, 20.0 with the various subnet mask, but finally it is summarized something like that. To the external world, this ISP, fly by night ISP, summarize the address something like this. It says like if the any packet destined for this address, please forward it to me. That means any packet, any address, any packet with the starting address 200.23.16 will come to this ISP, and ISP will distribute that packet to the particular destination. That is called as route aggregations. And one more concept is there that I have already told. NATing is nothing but mapping internal address into global address. Here in this example, you can see we have so many machines here. It is represented, 3 machines are represented, and we are using private address 10.0.1 class A address, but we are mapping so many address to one public address. So that means from the ISP we are going to buy only one IP address, and we are mapping that all these address into one IP address by means of port number. That is we know transport layer makes use of port address, so that same concept is used in the NAT. It makes use of port address, so it will map all these address by means of port address to this address, to global address. That is this concept is called as NATing. To summarize the next concept here, students, that is nothing but Internet Control Message Protocol. Internet Control Message Protocol works on IP layer itself. The main purpose of the Internet Message Control Protocol is it is used to report the error. Error reportings are something like unreachable host, network unreachable, or something like this. So the main tool like traceart, ping, that makes use of ICMP message. ICMP protocol. ICMP protocol makes use of ICMP message that carried in IP datagram itself, and there are different type of code for the messages. That is echo reply is type and code is 00. If destination network unreachable, destination host unreachable, destination protocol unreachable, destination port unreachable. So different types of code, message code and message types are there in ICMP. In this diagram, you can see here two end system, and user tries to check the connectivity. So when he sends ICMP packet by using ping utility, then first in the packet TTL is set to 1. After that TTL is set to 2. For example, when the TTL is set to 1, then packet reaches the first router and returns. That means connectivity is there from machine to first op. After that, the same machine will send the packet with the TTL2. That means now it probes 2 routers, and it will after getting response, it will probe 3 routers. Like this, it will send the packet to the destination to get the reply. So in this way ICMP works. So now the next topic in this one is IP version 6 that we will see in the next session. Thank you for your cooperation. Thank you.